Okay, hello. So, I'm just gonna hide this quickly and open it. So, for this discussion, what I did, I don't know, correct me if I'm wrong or if I'm right. I kind of looked at the Iowa sample mean and I looked at the Minnesota sample mean, and I kind of just only counted the ones that equaled 7.5. So, I went 7.4 all the way up until 7.54. I don't know if that's right, but to me that's how I got 7.5. So then I did it out of 50 since each of these are 25. And for the type 1 error, let me read it out. So if the null hypothesis really is true, the type of error to worry about is type 1. So if the null hypothesis is true, that is a type 1 error. The null hypothesis being true that Iowa and Minnesota have the same sample mean of 7.5. It's the sample means equal 7.5, so H naught and this will equal 7.5, and to reject it, it will not equal 7.5. So the correct decision, I got 17 out of both of the means that were, in my opinion, 7.5, and this is the ones that weren't. Okay, and so that was for true. And for true out of 100, I did the same thing, but I did them out of 200. So to retain it, I counted 33 that were at the 7.5 mean range, and rejecting it, it's the rest. Same with here, I did it out of 1,000 since you had 500 together. The correct decision, I got 60, so then I did 40. These equal 100. Actually, I forgot to mention because we do it 100 times. The 1,000 is because we're adding 500 of our n's together, or people, if that makes sense. So now going to false. So the false one has a type 2 error, which if we go back, that is if the null hypothesis really is false. The type of error to worry about is type 2. So type 2 error is when the null hypothesis is false, meaning the means they are not 7.5. So going here, and that equals power because it's correct. So one's not equaling 7.5. The ones not equaling 7.5 is right here, 81, because what I did when I counted the ones equaling 7.5, so I put that in the power, and the power is like what we want. So that's the power. Okay, so the next one, out of 100, I did the same thing. I counted 31 out of the 100 samples in both Iowa and Louisiana, and then I got 69 for my type 2 error. And then for my type 2 error, I got 42 here and 58 for my power, which means that I did reject the false hypothesis. If we go back here, again, reading it, if the null hypothesis really is false, that's type 2 error. Okay, so then the possible data. As you see here at the end, it's actually very interesting because when I put it all here, the more the people, the higher the correctly retaining, and less of a type 1 error. Which if we go back, the type 1 error, again, is if the null hypothesis really is true, the type of error to worry about is type 1. So we get less of a type 1 error the more people we get when it is actually true, but when it's really false, here we get higher of a power, which we want. Power is a good thing. And our type 2 error, which again, going back, if the null hypothesis really is false, the type of error to worry about is type 2. That goes down. So the impact of increasing the sample size on the probability of each type of error, the error goes down the more the sample size. So the more the people, the sample size goes down. Okay, and so for the last one, it says explain or demonstrate the impact of using a significance threshold of 0.01 instead of more common 0.05. So I kind of had trouble with that, so I looked it up on a website as seen right here, and it said the significance level is a measure of how certain we hope to be in our results. Low significance values correspond to a low probability that the experimental results happen by chance and vice versa. Significance levels are written as a decimal, which corresponds to the percent chance that random sampling would produce a difference as large as the one you observed if there was no underlying difference in the population. So the decimals correspond to a percent, and the smaller the decimal, the smaller the percent, the more confident you are. Something that I got out of it is I said the smaller the confidence interval, like 0.01 instead of 0.05, the more confident you are in rejecting the null hypothesis. The impact of using a smaller value is that you are much more confident in it not being wrong and rejecting the null. So let me know if you guys have any questions or any comments. Thank you.